Okay, so next on our list here is conversions using the metric system. You will probably notice that I do not have any conversion factors for you, and that's because you are expected to have these memorized, okay? Now, again, for this specific class, we're all at home, blah, 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 so you might have a piece of paper next to you. I don't know how the rules work, I don't know how you're taking your test, I don't know. But in every class, every science class you ever take, from here forward, the expectation is you already know your metric conversions. Nobody's going to be teaching that to you after this moment, okay? Anyway, yeah, it's important to make sure you spend time learning those. We're going to convert 5.95 times 10 to the 12th nanometers to meters. All we need to do for these is know our conversions. So let's go ahead and do that. 5.95 times 10 to the 12th nanometers. I know that there are 10 to the 9th, that is a billion nanometers for every 1 meter. So 5.95 times 10 to the 12th divided by 10 to the 9th. Now, we have calculators. We can solve this with a calculator, which we can certainly do. But it also might be important to get comfortable working with these exponents here. So I know if I have 10 to the 12th divided by 10 to the 9th, I'm just going to subtract 9 from 12 here. So this should be 5.95 times 10 to the 3rd meters when I'm done. 12 minus 9 gives me 3 over here. Now I'm going to throw this in my calculator because I'm not a sociopath, but it is an important skill to be able to do that. And the reason I say that is probably because I have just taken a very important exam. I just took an MCAT, and they don't give you a calculator for that, but they still expect you to do this stuff. So anybody that's looking at medical school, maybe your GRE is the same way, they're going to expect you to be able to perform these functions without a calculator, okay? So I did put in a calculator. It is in fact 5.95 times 10 to the 3rd meters. Now, is scientific notation appropriate in this case? The question specifically says, write the answers in scientific notation as appropriate. If I wrote 5,950 meters, nobody's going to bat an eye. So I could write this, or this is still pretty reasonable. Either way you want to write it, not a big deal. So in this case, who cares? Let's move on to the next one. Okay, in the second one here, this one, there's a little bit of a twist in here. You do need to know, and again, you should have memorized, that 1 milliliter equals 1 centimeter cubed. So we will be utilizing that at some point here. The first thing I'm going to do is, personally, I don't like to go from one unit to another that doesn't involve the standard. I didn't memorize how many microliters are in a milliliter. Now I know that they're 1,000 away from each other, so I actually know what it is, but I'm not going to waste brain power memorizing all the different relationships between all of them. All I want to know is what is the relationship between microliter and liter. And then I need to know between milliliter and liter. So when I'm going to do these problems for you guys, I'm going to always go through the standard on any of these things, okay? So in this case, we have 0.68 microliters. I know that there are 10 to the 6th, that's a million, microliters in 1 liter. And I know that for every 1 liter, I have 1,000, or 10 to the 3rd, I'll just write 1,000 milliliters. Okay, so now 0.68 divided by a million times 1,000. Now, if you're comfortable with the fact that there's 1,000 microliters in a milliliter, by all means, just go ahead and do it. But again, I like to go through the standard on all of these because that's what I memorized. Anyway, let's go ahead and throw this in a calculator, and we can solve it real quick. So I'm going to say 0.68 on the bottom divided by 1,000,000 and times 1,000. 6.8 times 10 to the negative fourth. Well, and you know, this is milliliters, and I got caught up talking about other stuff. For every 1 milliliter, we have 1 centimeter cubed. So this also is going to be 6.8 times 10 to the negative fourth centimeter cubed right there. All right, perfect. So, and now, again, the question, is it appropriate to have scientific notation? If you're -4, +4, or higher, it's probably reasonable to have scientific notation at that point. If you're at like 2, 3, 1, 2, 3, it's probably actually annoying for somebody to look at a 1 or 2 or a 3. Like if I wrote this as 6.8 times 10 to the negative 1 microliters, that's annoying for somebody to read because it's just 0.68. It's not a big deal. Okay. So in this case, I think that scientific notation is in fact appropriate. All right, cool. Let's go ahead and do the next one. Okay, so for the next one here, we are going from kilograms to micrograms. And once again here, I'm going to go through grams because I don't want to know how many micrograms are in a kilogram. That's wasted brain power, in my personal opinion. If you want to learn it, by all means, do it. You know, it'll go faster for you sometimes, but I like to go through the base unit, which in this case is going to be grams. So let's go ahead and get started. 3.55 times 10 to the negative 7th kilograms. I know that there are, for every 1 kilogram, we have 1,000 grams. And for every 1 gram, we have 1,000,000. Again, that's 10 to the 6th micrograms. All right, so let's see what this comes out to. It'll be 35.5 maybe. Let's see. 3.55 times 10 to the negative 7th times 1,000 times 1,000,000. 355. I was off by power 10. Okay, so this is 355 micrograms, and again, this would be 3.55 times 10 to the second. That's annoying for somebody to look at. 355 micrograms. We don't need to use scientific notation in this case. All right, and let's go ahead and jump right to the final one here. Okay, so this last one, I just wanted to use a unit that you likely are not very familiar with. This capital C is a Coulomb. It represents a unit of charge. And this is only to illustrate that these metric units apply to any kind of unit. It doesn't matter. You're talking about joules, kilojoules, millijoules, who cares, right? It doesn't matter. Whatever unit you're referring to, you can use these prefixes. So, that's part of what makes them so important and so widely used. So in this case, we have 1.609 times 10 to the negative 19th Coulomb. This is not a random number. This is the fundamental or elementary charge. This is the charge of 1 electron if it's negative, or the charge of 1 proton if it's positive. Just something I thought was interesting. Might come in handy later in the future. Who knows? So anyway, let's convert this to Nano Coulombs. So we have 1.609 times 10 to the negative 19th coulombs. I know for every 1 coulomb, I have 1,000,000,000, 10 to the 9th nanocoulombs. All right. So if I had to guess, I would say negative 19 plus 9. That's going to be 10 to the negative 10th here. But let's throw in a calculator to make sure. Let's see here. E to the negative 19th times 10 to the 9th. What do you know? 1.609 times 10 to the negative 10th, 1.609 times 10 to the negative 10th nanocoulombs. And there is our answer. And of course, I don't want to throw 9 zeros in front of this thing for somebody to have to read. Scientific notation is clearly appropriate in this circumstance. All right, perfect. Let's jump forward.